For a 0.748 gram sample of calcium carbonate, CaCO3, which was recovered from a sample of hard water, how many formula units of calcium carbonate were in the sample? So let's start off with 0.748 grams of calcium carbonate. So our first step is to find the molar mass of calcium carbonate. So calcium is 40.08 plus 12.01 plus 316. And from this, we'll get 100.09 grams, which is a molar mass of calcium carbonate. So the molar mass of calcium carbonate equals 100.09, so 7.48 grams of calcium carbonate. So we just start off with some simple dimension analysis. So we're going to convert from grams to moles. So in 100.09 grams of calcium carbonate is 1 mole of calcium carbonate. And our next step is to convert moles to formula units. So formula units is just the ionic term for molecules. So 1 mole of calcium carbonate is equal to, I gotta write this side here, 6.022 times 10 to the 23rd formula units of calcium carbonate. So all you gotta do now is just plug it into the calculator. So 0.748 grams divided by 100. Divided by 100.09, and then you multiply by 6.022 times 10 to the 23rd formula units, and you'll get 4.50 formula wait, my bad. So 4.05 times 10 to the 21. Can't forget that because that's just how many like formula units or molecules of calcium carbonate there are. Formula units of calcium carbonate. So in this problem, you can't forget about the significant figures. So since you started with 0.748, there is 1, 2, 3 significant figures. So your answer must have 1, 2, 3 significant figures. So when you write in scientific notation, or just any decimals after that, the 0 after the decimal point will always be a significant figure. So you got 1, 2, 3 significant figures. Methane, CH4, is a gas commonly found in labs. Oh, there's not supposed to be a D here. To fuel Bunsen burners. A. How many moles of CH4 are there in a 5.68 gram sample? B. How many molecules of methane are there in the sample? And C. How many atoms of hydrogen are found in the sample? So we started off with 5.68 grams of methane, CH4. So we need to find what's the molar mass of methane. So molar mass of CH4 equals 12.01 plus 4 1.008, which is which is 16.042. .042 grams per mole. So take this, and we can just put it right here. So now what we do is take this 5.68 grams of methane and you divide by its molar mass, which is 16.42 grams per 1 mole. So now we don't need this molar mass. Oh, whoops. CH4. So also another tip is don't forget to add these molecules, because you just like whenever you're working, like checking back on your work, you can just see which like substance or chemical are you working with. So that's like always a good thing to keep in mind. So we're trying to find how many moles of CH4 there are. So we can just calculate this right now. So 5.68 divided by 16.042 equals 0.354 moles of CH4. So you want to keep 3 significant figures because the answer that you started with, or the value that you started with right here, is only has 3 significant figures. So your answer wants to have 3 significant figures. So we can move on with, we can just like continue this equation for question number B, or letter number B. So how many molecules of methane are there in the sample? So we already have how many moles are there. So 1 mole of CH4 has 6.022 times 10 to the 23 molecules of CH4. So multiply 0.354 moles by 6.022 times 10 to the 23. And if you guys aren't familiar with this number is an Avogadro's number. So this will be pretty useful and is a pretty good number to memorize because you'll use this quite a lot in chemistry. And you'll get 2.130 2.1 turn up the brush size. 2.113 2.13 times 10 to the 23 times 10 to the 23 molecules of CH4. So right here it'll be 2.13 times 10 to the 23 molecules of CH4. So now we can just get rid of this part. So let me just rewrite how many molecules we got. So 2.13 times 10 to the 23 molecules of CH4. So in question number C asks, how many atoms, and no atoms of hydrogen are found in a sample? So we just take this M and C. So in each molecule of methane, there is one carbon plus 4 hydrogen atoms. So it'll be one molecule of CH4. There is 4 atoms of hydrogen. So what you do is just multiply this number by 4 and erase this. So you would get 8.53 times 10 to the 23 atoms of hydrogen. So this will be your answer for C. So over here we have the question, what is the mass of one atom of carbon-12? So first, the molar mass of like 1 mole of carbon-12 is 12.01 AMU, or U for short. So we're trying to find the mass of one atom. So in 1 mole of carbon, there is 6.022 times 10 to the 23 atoms of carbon in 1 mole. And this is basically all you need to do. So 12.01 times 6.022 times 10 to the 23rd atoms, you'll get 1.99 times 10 to the negative 23rd grams of carbon. And that's the whole problem. What is the mass of 3.46 times 10 to the 25th molecules of water, or H2O? So let's start with writing out how many molecules of H2O we have. So 3.46 times 10 to the 25 molecules of water. So first we need to divide by Avogadro's number. So 6.022 times 10 to the 23rd molecules of H2O equals 1 mole of water. So let's continue the dimension analysis down here. So in 1 mole of water, there is 18.02 grams of water. So that's pretty much all you need to do, and then you just like multiply it and divide out. So 3.46 times 10 to the 25 molecules of water, divided 6.022 times 10 to the 23rd molecules of water, and just times 18.02. excuse me, you will get 736 grams of water. So yeah, again with the sig figs, there's 1, 2, 3 sig figs right here, and 1, 2, 3 sig figs, and this is your answer right here, 736 grams of water. So in this question, it asks which have greater mass, 0.354 moles of carbon dioxide, CO2, or 2.83 times 10 to the 23rd molecules of carbon monoxide. So let's start converting each of these from moles or molecules to its mass in grams. So 0.354 moles of carbon dioxide, CO2. So 1 mole of carbon dioxide is 44.01 grams of carbon dioxide. The reason why I didn't do like adding up like carbon's molar mass plus 2 of oxygen's molar mass is because once you like use these molecules enough, you just like naturally just memorize how many grams are there in like for its molar mass. So once you do this, it'll be 0.54 times 44.01, which is 15.6 grams of carbon dioxide. So let's go over to the carbon monoxide. So 2.83 H3 times 10 to the 23rd molecules of carbon monoxide. So the first step is to divide 6.022 times 10 to the 23rd molecules of carbon monoxide is 1 mole. Is 1 mole of carbon monoxide. So now what you do is you convert the moles of carbon monoxide to its grams. So you have 1 mole of carbon monoxide is 28.01 grams of carbon monoxide. Right here we get 2.83% to the 23rd. We'll get 13.2 grams of carbon monoxide. So right here is carbon dioxide. It has a greater mass. So yeah. There's something that I want to show you guys. Oh, whoops. So we have the molar, like the number of particles or molecules that this carbon monoxide have is 2.83 times 10 to the 23rd molecules carbon monoxide. So how we would normally approach this is divide by 6.022 times 10 to the 23rd molecules of carbon monoxide, and then you just get 1 mole, and then like just like mole, so molar mass, mole, so molar mass. Well, like we don't really need to like create this second set of train tracks. So instead, what we can do is just, instead of like doing that, we can just multiply the molar mass by the molar mass, because there's like 1 here and 1 there. So like all you need to do is just multiply by the molar mass over here. if that makes any sense. So just multiply by 28. Wait, let me see, what is this? So 28.01 grams of carbon monoxide. And once you do this, 2.83 times 10 to the 23rd, multiply by 28.01 over 6.022 times 10 to the 23rd, you will still get the same answer. It's 13.1 or 13.2 grams of carbon monoxide. Alright, thank you for watching. If you have any questions, feel free to just leave a comment or